sometimes when the lava is actually erupting, here you can see in this, when the lava is erupting, so this lava, or let's say here in this case in the interior parts we have this magma, and when this magma is rising and being all the way through the crust and appearing on the surface comes lava, it will cool down. When it will going to cool down on the surface, that will be known as what? Extrusive igneous rocks. And based on the cooling parameter, when this magma will solidify in the interior part of our crust itself, that would be called as what? Intrusive igneous rock. So lava may erupt and cool when it will going to solidify beneath the crust or on the crust. Based on this cooling location, we have a plutonic or intrusive rocks, and the another division is what? Volcanic and extrusive rocks. Here you have a set of categorization. You have a plutonic and intrusive rock, you have a volcanic and extrusive rock. Intrusive means inside. Okay. When we have a solidification of magma in the crustal parts itself, as a result of that, we would have formation of igneous rocks, and such igneous rocks would be termed as intrusive igneous. These are formed by slow cooling. Here there will be a slow cooling. Here in the extrusive igneous rocks, there is a fast cooling. See, whenever there is a, suppose we have a lava, so this lava will instantly, in the contact of air, sometimes there might be a water as well. So when it is under the instant contact of air and water, so these extrusive rocks will going to cool fast because there is a fast heat exchange. Here we have what? Extrusive. With the extrusive rocks we have a rapid cooling, but the same aspect are not present specifically in the intrusive igneous rock, because there is no medium to lose heat, and as there is no medium to lose heat, there will be a what? Slow cooling. There will be a slow cooling. As a result of slow cooling, we would have what? Large crystals which would go into coarse grains, and these are actually found in batholiths. These are the terms which are associated with the volcanic landforms. You'll have a more clarity in some upcoming sessions. As of now, just remember that these intrusive rocks are actually being found in batholiths. These are being found in the lacholiths, sills and dikes. These are the volcanic land. We'll have some deep dive on this particular volcanic landforms. We'll see. Granite, gabbro and diorite are the example of this. And if you see the extrusive rocks which is actually taking place on the surface, so this will be, here we have a rapid cooling. Due to the rapid cooling, we have a fine grained glassy form of rock where crystals would not be there. So crystals are not here. These set of rocks are actually being found in volcanic domes or especially on the surface. Basalt, Obsidian and Pumice are the example of these set of rocks. Diorite is also one of the example of extrusive kind of rocks. So you will see the categorization on two parameters. First, based on the silica content, we discussed about the acidic and basic rocks. That was purely based on silica content, and based on the silica, some features were there. Here, based on the cooling location, we have some features and categorization in terms of extrusive and intrusive igneous